Hey folks! Epic Games recently partnered with Tribeca to create Writing in Unreal, a first-of-its-kind program that opens new doors for independent filmmakers, enabling them to gain first-hand knowledge from Unreal Engine experts and fellow colleagues on how to use Unreal in their filmmaking process and to craft their stories. Catch up on the incredible sessions, panels, and case studies at tribecafilm.com/unreal. Mr. Beast's recreation of Netflix's hit show Squid Game, where contestants compete in a deadly competition for cash prizes, is not only one of the most popular videos on YouTube, but demonstrates how you can leverage real-time workflows to create large-scale projects on a short timeline. So Crispy Media walks through the process, previs to final pixels, in their official behind-the-scenes video. Check out the sets, the shoots, and more on their YouTube channel. Sketchfab's 3 December is back! The challenge, should you accept, is to test your 3D skills with daily prompts. Now through December 21st, build something new and upload it to Sketchfab to show off your beautiful creations. Visit the challenge page to get all the details. Looking to dive into blueprints but you're not building a game? In our upcoming webinar, we'll cover the basics of blueprints and explore common elements for non-games workflows, such as interactive actors, animations, and UI elements. Register now for Using Blueprints to Enhance Your Unreal Engine Scenes, taking place on Wednesday, December 8th. What started as a zombie apocalypse mod for Arma 2 has transformed into the session-based PvE survival game Icarus, where players are dropped onto a dangerous planet to harvest resources before racing back to the ship. Hop over to the feed to hear from RocketWorks technical lead Ben Carnell on the game's unique approach to survival gaming, how they push the envelope on the look and play, and what players can expect from Icarus post-launch. In this week's Epic Online Services update, learn how to start using title storage to securely retrieve game-specific data from the cloud. The walkthrough covers title storage versus player data storage, usage limitations, setting up files in the developer portal, and more. Dive in at dev.epicgames.com/news. Now over to this week's top karma earners. Many thanks to Clockwork Ocean, Every Nun, Coding Rook, Shadow River, Devin Sherry, Luna Nellis, Agents Surf, Your Mom 1324, Werner 1990, and Intrick In. Get ready to turn up the volume with our first spotlight and in-engine music video for Nicole Markson's song Bones Dust from the EP Tether, released earlier this year. Directed and created by Richard Krause, we encourage you to watch the full moody music video on Nicole Markson's YouTube channel. Journey through a surreal world filled with mystery, high-speed traversal, and massive enemy encounters in Solar Ash, game dev studio Heart Machine's second title. Just released, play the vivid title from the Epic Games Store or on PlayStation. And lastly, Small Land is a big adventure on a tiny scale. Enjoy multiplayer survival in a vast, hazardous world. Surrounded by massive creatures, craft weapons and armor, build encampments, and explore the land of the small. Wishlist Small Land on the Epic Games Store and Steam. Thanks for watching this week's News and Community Spotlight. Hi, and welcome to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Amanda Shade, and joining me today is technical writer Mike Prickey. Thanks for joining.
Thank you, Amanda. So today I'm going to be talking to y'all about the Unreal build system. So we're going way inside Unreal today. Basically, I'm going to give you an overview of Unreal Build Tool and Unreal Header Tool. I'm going to explain how the build cycle works at a high level, and I'm going to... What the heck? Sorry, I should mute the thing. Anyway, I'm going to explain what they do at a high level, how the build cycle works, and how it impacts the way you write your code and organize your project files. So what you'll get out of this is a better understanding of the formatting for Unreal Engine C++ and a basically, I'm going to teach you how to make modules in Unreal Engine. So you'll be able to separate your code out into different modules, and you'll be able to keep better organization. And better yet, you'll have some idea of how to selectively compile or not compile a couple of things. And that's a springboard into a lot of other topics that we might cover in the future. All right, so let's start by explaining the big picture of what the build system is and what it's doing. So the main two components of all this are Unreal Build Tool and Unreal Header Tool. Basically, this is a custom build pipeline. It handles compiling your code instead of like the normal compiler that you would be using in Visual Studio. It actually is built on top of like a relatively standard compiler, but it manages the code a little bit differently. It decides how to put it all together in the end. And it can take in a lot of different parameters, like what type of build you're doing and what platforms you're supporting and things like that. So the way that the build cycle works, you hit compile, the build tool starts. It will scan the modules in your project, and then it'll ask, all right, has this code changed since the last time we built this project? Has any of the code in this module I'm looking at changed since the last time we built? If it hasn't changed, then there's no real reason to compile that module. This is one of the benefits of organizing code into modules is it will ignore things that have already been compiled and not waste a lot of time. You know, you'll have faster builds is what I'm saying. If the code has changed, it will take a look at each of the classes in your module and say, all right, are there includes to generated headers at the top of the file? And are there any uClass, uFunction, uProperty macros, or anything like that? There's a number of macros that Header Tool looks at to decide how to generate code for your project. If it finds those components, it will Build Tool will invoke the Header Tool to parse the file. Header Tool will generate additional C++ code in support of numerous features in Unreal Engine. And then after that, Build Tool will take over again and build all of the C++ code, which includes the normal precompile pass where it expands precompile macros, and then compilation proper, and then you get your binaries out at the end. So that's a basic overview of like the process. Each of these tools is doing some very specific things and looking at very specific formatting. I'm going to talk about Header Tool first. I'm going to try to keep the explanation of Header Tool pretty quick. But then I'm going to go into Build Tool and modules, and that's where we're going to spend the meat of this presentation. Before I go on much further, I want to give a shout out to Ari Arnbjornsen, who is one of our evangelists, and he helped surface a lot of this information about modules. We have generated some new documentation on the Unreal Engine docs site. You can find it in the C++ programming section under the programming, scripting, programming with C++ section. So we have Unreal Engine modules and creating a gameplay module, which is a whole quick start guide walking you through step by step how to make a module. So you can follow along by looking at these steps. One big heads up, there are some odd formatting issues. Those should be resolved within the day. But anyhow, let's go on with the show. Just wanted to say thank you, Ari, for all of your assistance. And now let us continue. So we'll start with Header Tool. So Header Tool, let me get up a class here that'll be a good example. So this is the source code for Shooter Game, which is a demo project that you can download from the Unreal Engine marketplace. It's a fairly frequently referenced sample that's got a lot of different a lot of different systems on display, uh, including things like automated tests for network gameplay and network gameplay itself. Uh, but I just want to uh, show you this to give you an idea of what an Unreal Engine class looks like and the things that Header Tool is looking at. So you see at the top there's this generated.h file that's being included. You've probably seen this a million times. That is the product of Header Tool. What Header Tool does is it parses your source code files for basically anything that is a U class or that has any of these different macros that you commonly see tagging up your code, and it will generate additional C++ code based on the contents of those macros. And what this is for is it supports the Unreal Reflection system. Reflection is a concept in programming that is usually found in more high-level programming languages. It's this ability for a program to examine itself and potentially modify itself while it is running. So it can see basically what functions there are, what variables there are, and it can access those for some very high-level operations, basically by name. At least that's a fairly high-level understanding of how reflection works. C++ does not have the ability to support reflection natively. Like I said, that's usually a feature of higher level languages. So what happens is Header Tool generates reflection info and various different functions and other bits of C++ code that are necessary to expose things from your U classes to the reflection system. And then after that, the editor can use that data to display a lot of information on the fly. So the details panels, any variable panels that you see displaying information about variables you declared in C++, and of course, Blueprint. The ability to make function nodes is dependent on the reflection system. So without Header Tool generating this data, basically you would have to support something like a node-based editor, for instance. You would have to write the nodes for each function and each piece of functionality that you wanted to expose to your node system from scratch. You would have to manually hard code them or something like that. For examples of what that's like, you can go back in time to Unreal Engine 3 and Unreal Development Kit, where we had Kismet, which was the level scripting system. And for Kismet, you did actually program different Kismet nodes in Unreal Script, basically hard coding them, saying, all right, I'm going to derive this class from Kismet event or Kismet function, and then I'm going to, I have this execute function that's in the middle of this class, and that will call the function that I need from this other class that I'm hooking into. And you'd have to manually register all of the delegates and all the stuff that's needed to hook into whatever entity you're trying to call this function from. It's a lot of busy work to do something like that. It's not hard. Like basically all you're doing is you're wrapping a function call in an object that represents that function call. And then that makes it possible to represent a function call in a graph as something you could move around. And then it's got metadata for like the X and Y values on the graph where it is placed. And then it's got like a GUID and maybe like a linked list kind of structure showing what the next node down the chain is and stuff like that. It's easy enough to understand, but it's just very time consuming to expose all of that kind of functionality by hand. If you had to do it for something the scope of what Blueprint does, where it exposes any function in your C++ code that you want, you wouldn't want to do it. You'd mainly tolerate that kind of setup for something with a very limited scope, like the AI system, where the behavior tree nodes, those you program basically bespoke the way that I'm talking about, where you wrap functionality in either a task or a condition, and then you have it returning information like, did this task succeed? Yes, no, and then it can branch. It's higher level reasoning compared with basic function calls, and it stands to reason that it has to be fairly bespoke to fit your game. And the same thing goes for the gameplay ability system. You write a lot of ability tasks by hand this way, because the exact execution and the exact timing of when different execution pins fire off is very important. So you have to necessarily do these complicated delegates and things that, yeah, you need to program it by hand. But for all of this other stuff, all the basic exposure to the editor and to Blueprint, you have the reflection system. And that is largely thanks to build tool. So these generated files, just to give you an idea of what's in there, I'm going to, didn't want to cooperate with me this time. Let me try hopping over to this one, I think. Yeah, okay, this project. This is the old ability system demo that I did a couple of episodes ago for Inside Unreal. And so this is the attribute set. This is just the code for the attribute set. Let me get the header up. Oh no, don't crash. Don't crash.
Nothing like doing it live.
Ah, boy. Wait. Yep, it crashed. It definitely crashed. It's restarting. Sorry, folks. Clumsy. All right, so now we've got the attribute set header file. You can see it basically just has a couple of gameplay attributes like the character's health, thank you, Whole Tomato Software. I'm aware Visual Assist is not activated. Strength, endurance, weapon damage, all that sort of thing. And then if we go to the generated file, this is significantly less readable, right? This is basically a bunch of thunks and function calls and things like that to expose information to the reflection system and the networking system. And it's not superhuman readable, but it is important. Sorry, talking at 100 miles an hour, and I have to remember what the next step is here. So, let's see. Okay, yeah. So, the question that we next have to answer is, all right, if I'm not going to edit this stuff directly, what practical use do I get out of understanding how header tool works? Well, for starters, I will say 999,999 times out of a million, you probably don't need to mess with header tool itself. You probably don't need to open it up and add new U properties or new U property specifiers or new U function specifiers or metadata tags or anything like that. You could, but you probably don't have to. Mainly what you get out of this is an understanding of what it's looking for. So it's looking for this generated.h, it's looking for the generated body macro, and then it's looking for other things like U function, U property, all of these macros that you commonly use to tag up high level features that you want to add to these functions and properties and things. So there's a couple of things to understand about how this is affecting the formatting of the code. For starters, of course, remember to add your generated.h at the top. This will automatically be added if you go through the class wizard in Blueprint. In the editor rather, the C++ class wizard in the editor. But if you try to write a new C++ class from scratch, like just bring up an empty text file and write it yourself, sometimes people can forget to add this. And that will cause header tool to throw a fit. It will expect this generated.h if any of these macros are present. Second, take note that the reflection system absolutely needs these macros to be in place in order to expose variables and functions to the reflection system. So I'm going to go find a U property here. So if you don't add this, then this property is going to be basically invisible as far as the editor is concerned. It will exist in the underlying C++ code for your project, but there won't be any way to see it in Blueprint or in the editor anywhere. There are not a whole lot of times when you would need to use a uProperty a uProperty macro, and basically have it empty without any specifiers in it. But it would be tempting to do that, to omit uProperty if you didn't need to explicitly use edit defaults only, edit anywhere, or Blueprint read write, or any of those other specifiers. You would think to yourself, oh, I don't need to make this a uProperty. But there are a couple of cases, namely in gameplay abilities, where you do need to do this. You do need to have an empty uProperty macro at the very least, and that's with gameplay attributes. Gameplay attributes depend on the uProperty macro, even if you're not planning to directly expose them, to be visible either in the systems that fill them out with data-driven attributes, so the stuff that populates attributes from a CSV file, or to be exposed in gameplay effects. So when you want to target an attribute with the gameplay effect system and say, yeah, I want to add or subtract this much, or I want to apply this gameplay effect calculation, it won't be able to find it without the reflection system, and the reflection system won't find it without the uProperty macro. So that is another thing to keep in mind. Then let's see what else. The next thing to know is that this generated C++ code is a middleman that is expected to be there for any given U class that you write, but it's not necessarily there by default, and it's not updated until header tool runs a pass on this code to regenerate it, as it were. So what can happen, this is especially true with network functions. So let's say server, be a server function in here. So server equip weapon here would be a good example. You've got U function, it's a server function, but if we go over to the definition for this one, it might not actually open because IntelliSense has no idea where the definition is. Basically, it's looking at this saying, hey, I've got a declaration for this function, but there is no implementation, there is no definition. But you did write one. We can find it going into private player and then going into shootercharacter.cpp, and then we want to find server equip weapon. And sure enough, there's server equip weapon implementation. So there's this weird suffix that gets added onto this network function in the implementation in your CPP file that isn't in the original declaration. And the reason for that is the definition for this function is not the same as the declaration for this function. The definition for this function is in the generated file made by header tool. The declaration for this function is also in the generated file. What's happening is there's a whole lot of middleman logic where the networking system has to bundle up information about this function call into packets and then send that information to the server when you're playing. And then when it receives that, it will call this implementation function and execute this function body, and then you'll get the effect that you wanted in terms of high-level gameplay programming. Otherwise, if this is being called on the server, then it will skip all of that network code and it'll just execute this implementation itself. So there's like a decision tree built in, happening under the hood in the world of the generated files. And that stuff, that stuff is basically standardized enough and consistent enough that why should you need to write all of that by hand? Why shouldn't there just be something that handles that code for you and handles this all according to a couple of rules for what you put in your ufunction specifiers? But the thing to know is this is what confuses IntelliSense so much when you're looking at Unreal Engine classes. It's seeing this and saying there's no definition because it's in the generated file, and it's seeing this and saying there's no declaration for this because it's in the generated file, and there's no definition for this because it's also in the generated file. So you have to compile your project at least once in order to get this. Or if you added a function to your project, you have to compile the project again to generate the necessary information for this to become truly valid. Otherwise, there's just this empty slot in between this header file and this CPP file. So that is just a formatting quirk to be aware of that probably a lot of people have run into, but they might not necessarily know why it happens. Let's see. And then finally, while this builds, there is one last caveat emptor with header tool to be aware of, and that is in your headers, you should avoid using if-def macros, particularly if they are wrapping different ufunctions or different other macros that are used by header tool. If-defs are a typical precompile macro that will comment out code unless you have met certain criteria. So if-def debug would say this, you have to be in a debug build for this to be compiled, and then else would say if you're not in a debug build, compile this instead. So if I were to put this inside of this if-def macro, then a bunch of weird things can happen. Basically, header tool will parse this and see this macro one way or another. Get my code back there. But this only happens on the precompile pass that normally happens during compilation. So this standard macro happens after header tool does its job. And so header tool will do something like generate all of the reflection data for this function, but then according to this macro, if you are compiling in such a way that it's excluding this code, it won't actually build the original function that the generated code is referencing. And so you'll get lots of ugly errors. So at the very least, be very cautious about how these are used, but generally try to avoid using them because header tool does not play well with them. How are we doing? How is everybody in the chat doing?
There are a few questions, but we'll hold those for the end. But
I could take like one or two. I could take one or two of them while I get ready to switch over to build tool.
So they were wondering if you could sort of explain the difference between generated uClass body, generated body, and the third.
Okay.
One. The ustruct body.
So generally, as I understand things, I don't have a complete understanding of what these are doing under the hood because they are, let's see if I can go to the definition for uClass body and show it. IntelliSense taking its sweet time. Yeah, here we go. So generally, these are, I don't want to say that they're inscrutable, but they're a little bit tough to understand when you lift up the hood, as it were. I'm not very familiar with what its underworkings are, but my understanding is that generated body is supposed to be the newer version of this macro that you're supposed to use, and it's supposed to automatically understand what type of object or what type of construct you're putting it in. So you could put generated body in a class or a struct, and it would do its job and figure out which one it's supposed to use. That said, I have a habit of using the legacy macros anyway, and using generated uClass body and generated struct body anyway, because I just feel better. It's like a superstition with me. But yeah, the differences between uClass body and uStruct body would be things like, it's generating functions and data for a class versus structs. All of the stuff that you would expect it to do. But yeah, the main one would be generated body is a newer macro that's supposed to be more versatile.
All right.
Any others?
Someone was asking, when packaging, how alarmed at various warnings should they be? So, for instance, they have some warnings with plugins that appear even if you don't enable them or aren't using them. So, any guidance around that?
Okay. Actually, yes. Very
Okay.
specific guidance around that, and that actually will segue into Unreal Build Tool rather than Header Tool. Okay, so after Header Tool does its job and builds this generated code, Build Tool will do its job and run the normal compile process. It will expand these different macros even further. So there's actually stuff that the macros themselves do in the normal C++, method, in addition to their role in Header Tool. And you get kind of a combination of what both of them do in your final code that actually compiles. But then Build Tool decides what to use based on certain criteria in your project and the way that it is built. So now we're going to get into target files, build files, and uProject files. So if you are having that problem where there is a plugin that you're sure isn't activated in the editor and that you're sure shouldn't be compiling along with everything else, you're not using any code from it, you're not using any features from it, first place to look would actually be the uProject file. Because what you find out is that a uProject actually is a text file in disguise. So basically, this is like a manifest of all the modules that are going to be included in your project. I'll explain modules in a second, and that includes your plugins. So you might have a plugin listed here that is not supposed to be there, but it'll try to include it anyway. You could, switch enabled to false to explicitly remove a plugin, or you could delete it from here, and that would tell it, no, please do not use this plugin with this project. The other place where you need to edit something would be potentially in, I'm kind of jumping ahead of myself here, but that's a really important question. That would be in your, not content, source. That would be in your build.cs file. So if I open this up, this is a file that declares a module as existing for the benefit of Unreal Build Tool. And it also defines the dependencies that the module has with other modules. You have one module in your project's source code when you first create a project, and that module is going to be the primary game module. And basically, this is where everything in the build process ends up bottlenecking. This is the final application that you're building, and this is what decides all of the other modules that are going to get included in your game. And so what you want to look at is public dependency modules, private dependency modules, and dynamically loaded modules, and see if there's anything here that shouldn't be there. If you put in, like, say, the ARKit plugin or something like that in one of these, it's basically saying this module needs to include code from ARKit, and it will try to include that in the build at some point, and so you want to get rid of it from there, and then that should finally purge all of my other windows from the screen. That should finally purge the unwanted plugin from your project. I hope that's a good answer to the question. So I got a little bit ahead of myself there. But that does segue neatly into what Build Tool does when it's compiling. So Build Tool actually ignores your solution file for your IDE, whether it's Xcode or Visual Studio or VS Code. The contents of this don't matter. It's not looking at the file structure in the Solution Explorer, and if I were to delete files from over here, you'll note that they still exist in your source folder, and when you try to compile your code, this is the Gasability demo, sorry, jumping between multiple projects. They will all still exist over here, and it will still compile those even though you deleted them from your Visual Studio solution. And then when you go to generate your project files again, it will just pop up like it never left. This is because the solution file is only there for your benefit. It is something created to make it easier for you to edit code and nothing else. Build Tool is otherwise kind of independent and can run without Visual Studio necessarily being the thing that calls it. It will go into your source folder, and it will go through each module in your project, and it will compile those as separate compilation units. So modules are essentially the building blocks that make up the code base of Unreal Engine and Unreal Engine projects. And yeah, that's the main thing about them, is they compile as separate units. What that means is if you're making an editor build, basically the contents of these different folders in your source folder will compile as separate DLLs. And so they can be loaded and unloaded independently, and they can be included or excluded from a build independently of each other. In addition to just being a good practice with encapsulation, right? It's a good organizational practice to separate your code, and this helps enforce some level of code separation. Let's see. So normally when you do this, you have a primary game module that is created. It will have the same name as your project. And at first you'll probably be really confused because you'll look at the source code for your module, and you'll just see the module, the primary game module, and it's just like, why is there a file with the same name as my project in here? I know that I'm editing Gasability demo here. I don't need the source folder to tell me that again. Why can't these all just exist in the source folder? The reason is because modules. The reason is that in a normal production setting for a larger project, you would have many different modules for many different systems, including the main game module, which is, again, the bottleneck where everything else ends up going, and then other modules for individual systems, like maybe your inventory system, or if you have a dialogue system or something like that, or even like lower level things like special compression formats that you need, or anything like that. Modules are basically arbitrary collections of code. There isn't any specific restriction to the type of code that you can include in them, except that you need to honor a dependency graph that is defined in your build.cs files. So this is actually what BuildTool is looking at when it tries to build your code. It looks at this build.cs file that needs to be in the folder for your module. So, your game has a build.cs that controls all of the other modules that this one's going to depend on. And then your other modules each have their own build.cs that also declare different dependencies for other modules in Unreal Engine that you're going to use. And if we look at, if we unfold the source code for Unreal Engine 4 over here, you'll see that there are a ton of modules defined for various different editors and features. So AI Graph, this is the AI editor. It's got a build.cs file. The Blueprint graph system, that's got a build.cs. The Niagara system would have a build.cs, and so on and so forth. And you'll see that it's separated into multiple other subfolders. Modules can be nested any number of layers deep in your source folder. So if you wanted to organize them like this, where you've got an editor folder and a source folder, an editor folder and a runtime folder, for instance, that is a valid way to do things. Or you could, try to separate the folders inside the module itself. So you'd have runtime, and then you would have public and private folders, and those would have folders for no, it wouldn't. No, that wouldn't work. That wouldn't work. I'm getting mixed up. This is the way you would do it. You would have a folder for editor, a folder for runtime, and then you would put editor-only modules in one and things that are supposed to work in your game in the other, and kind of keep them separated. You could put them just next to each other in the source folder. That's the thing that you're able to do. But this is just a little bit cleaner. Anyway, getting back to the construction of a module. So there is the build.cs file that tells BuildTool that the module exists, and it defines all of the dependencies. And these are references to the modules that you'll see in Unreal Engine code over here for the most part. So if you need to make a new user interface system or something like that, then you might put in, let's see, is it UMG or is it Slate UI? I wonder. Yeah, UMG would be one, perhaps. Let's see, and probably looking around for Slate. Yep, Slate and Slate Core. So these might be extra dependencies that you have to add to your module to be able to access these modules and their classes. Basically, when you're writing your source code, this is another quirk that comes with working in Unreal Engine code. You could try to access a function or extend a class from one of these, but you'll run into a roadblock when you do the first compile, and it looks for the includes, and it says, sorry, I can't find that class. The reason that happens, even though you know it exists over here in the engine source, is because it's not added as a dependency yet. You can get around this, I think, by doing like really explicit includes where you add the entire like folder path, navigating backwards and into the engine source and into the folder where it exists. But just add it to the dependencies, and then you have immediate access to any class, any function that is contained in here. Let's see here. So that is the gist of a build.cs. I will go into the difference between public and private dependencies in a little bit. But for right now, I want to kind of move on to other aspects of how these are composed. After the build.cs, every module has a private and public folder, and these contain your actual source code for your module. So all of the Unreal Engine classes that you have to write, they go into these folders. You can put them outside of these, and you can nest public and private folders into other folders, I think. Trying to remember if that's true or if I'm getting that mixed up with something else. No, I think you can put other folders inside of them. I've got it backwards. Apologies. So you can organize the contents of these how you like, as long as the folder structure inside each of them is parallel. So if you add a folder to say, let's say player character stuff goes in this folder, you want to have it in both private and public. If you make a class through the Unreal Engine, the Unreal Editor C++ wizard, it will automatically make this parallel construction for you, but it's just something to keep in mind. But what these do, these are not related to the public and private specifiers in C++ code. So when you when you do this kind of thing to designate public and private functions, these are related to basically how Build Tool chooses to expose their contents. So not only can you include modules inside of other modules with your build.cs file, you also can decide to selectively exclude certain classes and certain C++ files from being accessible to other classes, even if they have visibility to this module. So if you put a class into the private folder, specifically if you put the header file into the private folder, then you won't be able to extend this class in another module. You won't be able to extend anything from that header in another module. You won't be able to inherit functions or anything like that. It will exist purely inside of this module. Its contents will be visible to other classes in the module, right? So internally, it's all going to follow the normal rules of if you put public, private, or protected specifiers in your C++ code, but outside of this module, it won't be available. Whereas with public, it will be available. It will be there for you to use in other classes. Generally speaking, you want to avoid exposing more than you need to, but it's pretty easy to move things between these different folders. Just make sure that you're not extending something important if you try to move it over to private. Use your best judgment. You can put code outside of these folders, and then it will basically be treated as private. So if I were to write if I were to put this header and this CPP outside, this would be valid, and it would basically treat this piece of code as being private. It wouldn't be available outside of the module. You should probably stick to this convention. Just for clarity's sake. But if you were working with code in the gameplay module, like the primary gameplay module, you could easily put it in the source folder directly without having to go through the private and public folders, because you're basically not going to include your game in another module. This is the endpoint for the inheritance tree, as it were, for all of the modules in your game. Aside from that, there's resources and content folders that could show up. So, a couple of things that support stuff that's written in the C++ code, like icons and things, can be put in here. But for the most part, it's mainly just going to be the C++ code that you're writing. So aside from that, one thing that is often needed for a module, let's see if Shooter Game actually has that inside of the... I want to look at the loading screen. There's the build.cs, shooter game loading screen.h. So this is going to be, yes. Okay, this is the module's implementation file. And what this is, it's a C++ file that declares your module as a C++ class and basically exists to expose the module to C++, make it visible to C++ code. This example is a little bit unusual because it's actually been manually written. Sorry, tripping over my words here a little bit. The module implementation class is extended from iModule interface, which is basically an interface for handling the loading and unloading functions for this module. So when you say start this module up, there are several functions here that will run that happen on startup and on shutdown. And the construction of this is parallel to the basically to the game instance class in your gameplay module, which is, that's the script that is universally available throughout your game, and that has the startup and shutdown stuff that you can use to attach certain processes when you begin and end. We went over that in the chunk downloader setup, where we used Blueprint to activate and deactivate the chunk downloader module, basically. But most of the time when you're writing this file, when you're writing the implementation file, what you're going to do, I'm going to actually get one ready here because I want to show you how to construct a module, not just give you a tour. I'm going to say, let's say I want to make a separate module for the add-ons I make for the ability system. So that's going to be my gameplay attributes, any extensions of the ability system component and things like that, I would make a folder for that module. I would take and make a build.cs for it. So I will cheat here and just go in and copy paste this, call it ability demo ability system .build.cs. And then I will immediately go in and see, did I get this backwards? Yeah, ability demo. Yeah, I got it backwards. I'm getting a lot of things backwards today.
You got it.
Nerves, you know, every time, no matter how much I prepare or rehearse for these, I'm always a little bit nervous because I'm explaining something that's big and important. Okay, ability demo, ability system, and then I've got it here, and then I put the constructor here, and this is actually a C# script, not C++, for those who might be wondering. And then I will get rid of those. Maybe I'll keep a couple of these. I don't want head-mounted display. That's probably one of those ones that gives people's headaches. You know, head-mounted display is included in every template project, but you don't necessarily want it for a lot of the applications that you want to make. You know, anyway. So I'll keep all of these here. Private dependency modules. Do I want these to be private or do I want them to be public? So I need to look at my notes for a second to remember what the public dependency rules are and what the private dependency rules are. I think I remember, but okay, so right. So what you want to do with these are both defining other modules whose code you're going to depend on and who you're ostensibly going to include inside of this module. The private dependencies are what you should use if the classes that are in these modules are only used privately. So if you're going by the include what you use paradigm, you would only see them included inside of a CPP file. If you need to include them publicly, so in a public header file, where it has to have some like throughput to the previous modules in the chain, then you would put it in public dependency module names. So, you know, basically the rule of thumb is if it's only in the CPP, if you're just using forward declaration in the header and you're actually including the code from this module in the CPP, you would put it in private dependency module names, and then that prevents there from being too many things getting overexposed and too many things needing to compile needlessly. And that's basically what these two things are for. But yeah, you declare the class, it's got the same name as the module. You put the constructor here. It is it takes in these read-only target rules, and then you add you call these functions to add information to the various different dependency lists. And that's what that's all you do with the build.cs. So we've got this set up. I'm not completely sure if these need to be private or public. I will circle back around to that in a minute. Then we go into the public and private folders here. And we create in the, I think it's the private folder. Let me double check this. I've done this over and over again, and I still need a cheat sheet. And I think that's
a lot
true
to keep
for,
straight.
it's a lot to keep straight, yeah. So hopefully this material is helpful for people. Okay. So, yeah, the header is public for this. I'm going to put in a .h file .h. So this is the same name as the module, and then I added the suffix module to it. This doesn't depend on a specific naming convention. This is just for your benefit to be able to find this if you're browsing through the Solution Explorer or something like that. Adding the suffix module to this just makes it clear what this file is supposed to be. And actually, come to think of it, I actually don't need this. I actually don't need the header file. If I were writing the implementation file from scratch, I would need to do that. But all I have to do is make the CPP file, and I'll show you why. So there we go, same idea as before. And now I will edit this. I'm just using Notepad++ because I am stubborn and like Notepad++. So the thing that you need in this implementation file is very simply this. You include the module manager, and then 90% of the time that you want to create a new module, you just call the macro implement module. You feed it fdefault module impl, the struct default module implementation, and then you give it the name of the module. And this has to be the same name as your module right here. And then this macro will expand to basically an empty extension of the iModule interface that's listed here. And then that will give it all of the startup and shutdown functionality that I was talking about, and it will make it possible to see your module in C++ code. The reason you would want to do this manually like this, where you manually extend iModule interface, is if you have very specific setup or cleanup that you have to do when you use this module in your game. So with the loading screen, this is conjecture on my part. With the loading screen, I would figure that you unload this, depending on what this is. If this were like the splash screen at the beginning of a game, right? I would figure you would unload it after you're done. Like you would have some shutdown logic that would get rid of any stray references to the loading screen and then shut it down safely or something like that. But I think this is something a lot more general, like the actual in between levels loading screen. But that's just like a quick idea of something that you'd load and unload. Similarly with Chunk Downloader, that is a module that you can start up and shut down manually, I believe, or at least a lot of patching systems are. There's a number of different systems like that where you might need to do some cleanup and you might need to do some different setup, and that's why you would manually create this implementation. But for the most part, if you use this default implementation macro, that's all you need to do, and it will handle everything that you need just to get the basic access to this. Okay, so we've got the C++ implementation, we've got the build.cs, and now we need one last thing, well, two last things. First, we go into Gasability Demo, and we go into that build.cs file. And guess what we need to do? We need to, let me see here, we need to add this as a dependency. So ability demo, ability system. And now it knows to include this in our project. And then finally, well, it knows to include this in the main module for the game. And now we just need to open up the U project, and we need to add as an additional module for this. We give it the name, and we give it a type. And then, just for kicks, the loading phase, and I'll explain. Runtime, loading phase. Gosh darn it, quotation marks. Quotation mark soup. Okay. Name, type, loading phase. These are kind of the bare minimum things that you'd specify. If you don't specify the loading phase, it will go to default anyway, but it's nice to be specific so that if somebody is looking at this U project file, they can see exactly what your intention was. So this is basically a manifest of the all of the modules that are going to be included in your project, including the plugins that you want to include, like I said earlier. It needs the name so that it can match it up to the module folder that you made. And then the type is basically, how to explain type? There are a number of different ways that BuildTool can compile a module, and this is one of the primary things that determines that. A runtime module is one that is going to be included in both editor builds and in standalone builds of your game when you try to publish it. There's also the editor type. So let's say I wanted to make an editor module where I want to make custom editors for my my game's specific type of abilities. I would do that. I would put type editor, and then it will know to only include this when building an editor build, basically. That is, in a nutshell. I think I've got to add commas here because this is a list, pretty sure. Yeah. There are many other different types that you can use in your projects. So for example, if you look at the eHost type API reference, this is the full list of all the different types of modules. So you can see there's editor and runtime here. There's one that handles like bizarre, like external program use cases that I don't know a whole lot about. There's server only, client only, and so on and so forth. Lots of different ways that you can control when this module is going to compile and when it isn't. But 90% of the time, you're going to be using runtime or editor, and not most of these other ones, I think. The editor stuff, that's how the editor code works in Unreal Engine. You put it in one of these modules here, and then its type is going to be an editor type, and then all of the editor information for whatever system you're building will get stripped out when you compile for a standalone build. And that's just like one axis on which build tool can decide to include or exclude code. Loading phase is a little bit different. The loading phase for a module is when is this module going to be started up, and during the startup process for your game. Every one of the different loading phases except none so that one, every one of the loading phases except none happens at some point during the startup of your game. And a couple of examples of them: there's default, there's pre-default, there's post-default, and then there's a couple of other ones for like during the initial splash screens. There's one called earliest possible, which is exactly what it says on the tin. Most of the time, if you're programming gameplay stuff, you're going to be using either default, pre-default, or post-default, I think. In fact, 90% of the time, you'll probably be using default if you're doing like gameplay programming or UI programming for a game. The reason you would use pre-default is because you're working with plugins. So what happens is default is when the main game module loads. So if I go back to Shooter Games source code, when this module loads, that's when default happens in the order of the different loading phases. And then after that is when all these other modules get after that is when all these other modules get loaded. But it works a little differently depending on whether the module exists in a plugin or whether it exists in your main source code for your project, like this module here. Stuff that's in your source code directly, that's in the project directly, you can pretty much leave as default. You don't have to specify the loading phase at all. It will understand that this is when it's supposed to load up. Plugins, I'm getting ahead of myself a little bit. So imagine it loads the ability demo module. Yeah, okay, I'm okay. Sorry, getting my bearings here. Okay, it'll load the ability, this ability demo module for the main game, and then it will see that it depends on these modules, and it will also load those up to support it. That is basically the thing that makes it so that you can leave these at default. With plugins, this is an external like project. A plugin is like almost like a mini project in terms of the way that it's constructed, that you can include or exclude from proper Unreal application projects. So when you say loading phase default for one of these, something that can happen is it will take that seriously and say, all right, load this after loading the main game module. And so what happens is you open up Unreal Editor and it loads the main game module. Once it opens the editor, that's the first thing it tries to do. And then it will see that you have derived classes in your main game module from a plugin, except the problem is that plugin hasn't been loaded yet. So what ends up happening is it spits an error at you saying, I can't find this class that this blueprint is extending, and then it just quits. It just clears out the entire thing, and you just have blank actors sitting around, or you don't see any sign of any of the stuff that you made. It's blank. That's because it's trying to load this plugin after it loaded the module, and the module needs this to be loaded ahead of itself so that objects that depend on code that's written in the plugin can properly find it. And then that's the really mysterious thing that trips people up a lot, is they will have this happen. They'll try to recreate the blueprint class that was extending something from the plugin, and then it will work. It will work just fine. It seems like it finds those classes just fine, but then they close the editor and they come back later and it blanks it out again and gives you all these errors again, because of the nature of module startup. So very often, if you're writing C++ code that needs to be extended in Blueprint, you do pre-default for plugins, and that will load them the way they need to be loaded. So let's see. What is next? Right. So we've got this U project. We have this extraneous module that doesn't exist, so I'm going to get rid of it. We have the one that I'm actually trying to write here. So now we're going to go back here, and I believe everything is in the place where it needs to be. We're going to go to our U project again, and we're going to hit, that's shooter game. That's shooter game. Gasability demo, generate Visual Studio project files. Please do that for 427 and not any of these other versions. Is it going to do this? Is it going to cooperate with me? Couldn't set association for project. Check that file is writable. Is there something silly happening here where, okay. Oh, it's because I've got this open. Make sure that you have the editor closed, probably before you start doing really extensive modifications. Normally, you can refresh the U project file with everything open, but it's probably got some kind of hold on this. Still giving me this problem. Let us go into properties. It's not read-only. Wonder what it is doing here. So it should be seeing that this is in 427. Okay, I will try a different method. That's so weird. I just had this open.
If it could be a syntax error either in the U project or maybe try closing Visual Studio.
You know what? That might be it. Let's
They also noted a missing comma somewhere.
Missing comma. Oh, type runtime there. That's probably it.
There you go.
Yeah. Yep. Missing comma every time. Yeah. So if you don't write this correctly, if you don't write this correctly, then it will fail to associate project version, and this just won't be useful. So now I hit generate project files, and it actually works. Hallelujah. Now I can hop back in here. It will load up. Again, this Visual Studio solution, nothing to do with the build process. It is generated based on the build.cs and target.cs stuff that you've got in your file system. And you can see here, I've got Gasability demo, and then the ability demo, ability system folder shows up. But the real proof in the pudding is going to be when I open up the project itself. Now it has to actually build that module for the first time. So it's going to call up Unreal Build Tool and tell it, please build this. And then it opens up. And now the real proof in the pudding is when I go to make a new C++ class. Let's say I take actor. If I click this drop down, you'll see not only do I have the main game module listed, I also have the module that I just created, and that is our sign that the module was created correctly. We can stick things into the public and private directories. We can add more stuff here. So this is what I was getting mixed up about earlier. You put this parallel construction in here under the public and private folders, and the wizard will just do it for you. So you see header file, it's under public, source file is under private. I can make this 100% private because this is, no, I don't want to make this 100% private. This is in the module, not in the gameplay, not in the main game module. The main game module, you can afford to make lots of things private because it is the end of the chain as dependencies go. Here, I want this module, the main game module, to see the ability system stuff I write in here. So I'm going to put in test actor, create that class. It regenerates the project files because it just added a new class. And we have a failed compile. So let's see what the log says. Changes to generated code not allowed. I must have done something very silly. Interesting. Let me take a look at the Visual Studio Code now. Got to reload it. I didn't accidentally edit the generated code, did I? I don't think I did. Here's test actor. It's including the generated.h. It's a U class, so things are kind of how we expect it to be. If I hit build in here, what is build tool going to tell me? Famous last words. That's never happened before. And now the build succeeded. Okay, I'll take that.
Ta-da!
So now we can go in here. We have a successful build. We do need to close and reopen the editor for a lot of things to take effect. So kill that. Go back in, and you can see under C++ classes, now that there's actually a class in here, it will show up in these drop-downs under C++ classes. And if you're not seeing that, you click this collections, no, not the collections view thing. You click this, the show or hide content sources panel, and then you can go to, everything is located in different places in UE5, so I'm remembering where everything is. And then you go to view options down in the lower right and make sure to do show C++ classes. And then if you want to see a bunch of other stuff, you can toggle on plugin content, and it will show any plugins here that you're including from your project as well. So now let's hop back over here and actually move some code into this. Let's go to the attribute system. Let's see, I don't need shooter game anymore, I don't think. Source, ability demo, private, ability demo attribute set. I'm just going to move this. I'm just going to move this over to the ability system, public attributes, put that here, put the CPP in the private folder under attributes. So now the attribute set is moved into its own module, and I can do similar things with any of the other files that I've made. This is dangerous moving code around like this. You'd rather make the modules first thing when you start building your project and add the source code the normal kosher way, like I did a minute ago with that actor. But this is just to get kind of a test case going and give you an idea of what you would use this for in practice. Generate my project files again, go back into Visual Studio. I'm so happy that somebody spotted that missing comma.
No,
That's
group programming works really well when you're live.
yep,
So
yep.
chat's always a great help.
That's the thing that always burns me when I edit UProject files, and every single time I act surprised when it happens. Okay, so we're back in this source code. Is the attributes? Yep, the attribute set has been moved. Now, if I did everything correctly, yeah, okay, this should be all fine. It should be possible to get away with, let's take a look at the .h. Okay, so if I want to include this in CPP files, then it's got to be in the private dependency rules instead of the public dependency ones. So let's see, ability demo, ability system, okay. Gameplay tasks, abilities, tags. Yeah, I don't think that I need to. I think that I can get away with these being forward declaration. I know that the attribute set, let's see, is using the, is it though? Is it really? Gas ability demo attribute set.h. Yeah, okay, this is the CPP. Getting all turned around as I'm jumping between too many files. So ability system component, attribute set, those are both things that are being included in a public header. So I actually want to go into this build.cs and I want to take gameplay abilities and I want probably to put it in public dependency modules instead. And that should do it here. And then when I look at the project, the main module, go to that build.cs, I can probably get away with this being private because I'm going to be adding the references to this mainly in execution of code rather than declaring the ability system and needing to include it in a header. So I think that this is all fine the way it is. So we should be able to hit build. Okay, it did not open gas ability demo attribute set.h because something is wrong with how it's including this this file, I think. So what should happen is we have the dependency set here for our custom ability system stuff. It should see that. I'm going to try moving it to public dependencies instead, just because I'm superstitious. Just in case that is actually what's going wrong. Okay, you know what? I know what it is, actually. Pretty sure I know what it is. Move this back where it is, where it belongs under private. I think I was actually right about that. And then the thing that we forgot is the include path. So the include paths for any of your modules are going to be relative to the folder that they exist in inside of your source folder. So if you have this in a folder like attributes here, so it would be attributes / ability demo attribute set .h. That is how you would include this. So let's go to the include where it is broken. And then we add, running into all sorts of gotchas here. It's
But
delightful.
this lets folks see how you go about debugging some of these issues. So I think it's a great, as much as it may not actually feel very good to show it off, I think it's a great learning moment to see how you approach trying to find those issues. So
Yes. Yes, indeed. Okay, this is including the attribute set, so attributes like that. And then I think that's going to finally do it.
it's always the hold your breath moment.
Ow! Now that's interesting. The generated file is not being pulled in for the attribute set. After all that talk about all the stuff that Header Tool does for you, okay, well, that's an example of some of the error handling. Okay, so gas ability demo attribute set generated.h. Does this need to have? I don't remember ever seeing this sort of path for the generated.h files, but maybe that's actually something that you need to do. Nope, that is not supposed to be there.
Comment about type not exported outside of module, parentheses no _ API macro.
Let me see where did you see that?
This is a comment in chat.
Probably in the log here, which I should pay more attention to. Okay, unresolved external symbol, private static class, demo attribute set, one unresolved external. That's, go to output here because this is going to be a little more informative. Okay, so it hits melee damage execution, unresolved. Okay, the damage execution is not finding this. Okay, damage execution, right. Remembering all the pieces that we had in place. This is why it's dangerous to relocate stuff as opposed to building it from scratch the correct way.
They're also asking if the editor is open. And would that cause the problem?
Open. I don't think that would cause the problem. I think it would hot reload. That would prevent a lot of windows in the editor from updating correctly. It would prevent some things in Blueprint code from updating directly, but it's not going to be, I don't think that that's going to, yeah, okay, this melee damage statics. Let's see here. Damage statics, return damage statics. Define attribute capture. And it's going for UGAS ability demo attribute set. So this is not finding the attribute set over in this adjacent module. So what is going on? Why can't it find that? Attributes, no, that's right there. Unresolved external symbol. Fascinating. Famous last words. That's never happened before. This has probably happened dozens of times before. Okay, so that include path should be right.
Class, your module name underscore API, your guess attribute set class.
Class API.
So module.
I wonder.
Module dependency.
I wonder actually. Let's go back to the attribute set for a second. Okay, it doesn't have any special. I'm a little bit surprised. I'm a little bit stumped. Let me see. Go back over to the damage execution. Let's comment this out and see if something else breaks. That's one way to do things. Although that is going to break a zillion other things now that I'm looking downstream at all this other stuff. So maybe not. What I might need to do is actually move this damage execution into the module as well.
So multiple folks are asking about underscore API. And so they're saying when you create a class in the wizard, it automatically adds the underscore API macro to it. So the attribute set needs the module API in the class definition.
That may be true. That may be true. Let me see here.
We'll
I don't know everything. I don't know everything.
This feels like the Unreal Engine version of Let's Play. Let's debug.
Yes. just a little bit. So some GDQ strats here. Okay, so I go to the attribute set and I add that alongside it. Let's kill this. Yep, that is how that's declared. Let's try it again.
Here we go.
It's doing something. Succeeded. Good job again, chat.
Huzzah!
Brilliant. Yes, okay. So this macro, I'm going to need to look up more information on exactly what these API macros do. I used to know this off the top of my head, but I'm kind of stumbling right now. So I'll have to get more details on what functionality this is bringing in that makes this visible to the project, the main project module. Yeah, I'll have to look up more details on that. Apologies for the time spent dealing with this, and thank you once again, chat, for saving my behind. All right, now that's built, and we now have a proof of concept of the ability system, some of the classes existing in this module instead of the main game module. And I can move classes over like this. I can move all the different ability system classes over like this, and this will be basically my custom ability system module with the attributes that I want, the ability tasks that I want, and the ability system component that I want, right? So that is an example of something you could divide out into a separate module and treat as a separate system. The idea here is you want to create encapsulated functionality as much as possible. You want this to be self-contained and reusable. So theoretically, if I did populate this with more ability system customizations, I could pull this entire module folder out of the source folder and put it in a different project. and then add it to the dependency rules, add it to my uProject manifest, and that would basically pull all of this code over without a whole lot of mess. So there is this added reusability and the sense of organization. Additionally, one of the important functions of this is the dependency chain. So going back to the build.cs, where you are declaring these different modules that you want to inherit from, basically, if you put a module in your source code and it's not anywhere in the chain of dependencies that are named leading from your main game module down to like the base editor modules, that's how you can kind of visualize this as a dependency chain. So gameplay tags and gameplay tasks are included here. Then the demo itself, the main game module, includes the custom ability system module. So it's kind of daisy chaining dependencies together to give build tool instructions on what is going to get built when you compile your code. Anything that's not included in that dependency chain is going to be omitted from compiling. So if I didn't actually add the ability system stuff to this build.cs, and I didn't add it to the uProject, then it just wouldn't bother compiling it. You would hit build, and you would see one succeeded for, well, you probably wouldn't see one succeeded. You'd probably see one failed. The point is that it would skip compiling that module because it's not identified as being needed anywhere. And that is one of the main things that you get when you separate code into modules, is the ability to not only activate and deactivate them at runtime, but also the ability to include or exclude them from being compiled under certain circumstances. So I can go back to the uProject file and I can look at this and say, all right, I really only want this to be available for game console A, right? So let's say you've got a module for like that console's online subsystem API or something like that. Like their storefront and their backend for handling like achievements and that sort of thing. You don't want to include console A's online subsystem API in the build for console B. So you could define the modules for each of those as being exclusive to one specific platform by using the include platforms field, and then the include and exclude platforms field rather, and then that will make sure that you don't accidentally put in code that's not supposed to be there. And then the idea there would be that when you have systems like that, you have a generic interface like iPlatform patching interface or something like that that has all of the function calls that you need, all of the things that you need in order to interact with these subsystems the way that you want, and then you just make different implementations of them inside of these different modules, and you selectively load or unload one or the other based on the platform that you're on. But yeah, this keeps you from even including the erroneous code at all. And there's lots and lots of different utility for that in many, many different use cases. Platforms, different architectures, obviously runtime versus editor builds, all that sort of thing. Maybe you've even got something that is really only useful for the dedicated server, so you make it a server only type. Like maybe it's a security protocol of some kind. Um, just a couple of examples off the top of my head of things that you might need to include or exclude. But aside from that, it will also, like I said earlier in this talk, when you go to build your project, it will detect which modules have changes in them and which ones don't since the last time you built. And so any module whose code has been built and unaltered, it will just keep the binaries that it generated from the last build because they are separated completely from the other compilation units that make up the other modules. So you don't have to you don't have to recompile it. All of the stuff that exists will work fine, and then that will basically cut down on your compile time a lot. It will keep you from having to regenerate the entire project all at once just because you changed one header file, right? That's not necessarily critical if you're making a small project. If you're making something that's like a fairly simple mobile game, or if you're making something that's just like a personal project that you're using to experiment with one system or another, like Niagara or something, you don't have to go and do this kind of thing to organize your project in those kinds of circumstances. But as a project grows over time, as you start to approach something that is more like a publishable project, that has a significant scope, something like a 16-bit RPG or platformer or something, right? That would be the type of scope where this starts to get really useful and where you start to save all the programmers a lot of time when you go to compile and it doesn't need to do every module in your game. So ideally, you separate out different systems in your game as much as you can into different modules, and you try to think ahead, what stuff might I want to reuse later in other projects? What stuff might I want to be portable or kind of generic? And the more generic it is, the more that you would want it to be a module. Whereas the more specific to the exact execution that you see in the game, if it's like an enemy or something, then it could exist in the main game module instead. Although you could probably define lots of different enemy types in like an enemies module or something. But I think that you would probably extend those as blueprints instead of writing C++ code for them. But I don't know, maybe people would write those as C++ code. Anyway, so that in a nutshell is modules. I kind of segued into modules without talking about targets. So another thing, this is going back to the axis of like selectively including or excluding things. These target.cs files at the top of your source folder basically are declarations of different types of builds you want build tool to be able to do. They extend from this target rules class. They are also C# files, and there's just like this constructor that runs, and you treat it a lot like you do the build.cs files, where you specify a lot of information inside of this, and then when build tool goes to make a build, it will read this and it will run a build according to the settings that you put in this build target. So one really good example of this, I thought I was done with Shooter Game, but I wasn't. One example of this would be a server build target. So if you want to make a dedicated server, then you set the type to target type server, and then that's going to be the dedicated server build. And that's basically it. That's the thing standing between you and deploying dedicated servers, or at least the main thing standing between you and deploying dedicated servers. Lots of people don't know about this because it is a feature that's only available in C++ builds. Not because it necessarily has anything to do with your C++ code itself, but because you need this target.cs and it needs to be in a source folder, and you don't have the source folder if you don't have a C++ project. But that's a good example of what an alternate build target looks like. And a lot of the time, the contents of these are going to be pretty slim. So target type.game is a pretty standard target type. Let's see what some of the other ones would be. I'm going to go and real build targets. So if you look at the documentation for targets under production pipeline, build tools, Unreal build tool, game is the typical standalone application. Client will specifically exclude server code. It is only usable as an end user's client, and it can't host any networked games. It can only connect to network games. And then similar with server, it will be able to make a dedicated server, but it's going to strip out things like a lot of rendering features that are not necessary because dedicated servers are headless builds. Editor will be specifically a deployment of the Unreal editor. So you can actually build and package up the editor and have that available for modding. And then there's program, which the description is a standalone utility program built on top of Unreal Engine. I don't know what that use case actually is. That is something that I'm going to need to look into in more detail. But those are the main things that you would change. There are other properties that you can add as well, like platform. So that might be like platform.android or something. Should probably be modifying this inside of Visual Studio so I get nice, neat autocomplete stuff instead of in here. Let's see, go back to target.cs. So platform. Nope. I'm going to need to look for what exact. Oh no, Unreal Target Platform. There we go. That's probably going to be. I'm wasting time. There will be similar specifications for different target platforms and different target architectures. So you could get as specific as saying, I want this to be a Mac build and I want this to be only used for ARM64 Macs. So this would be a target specifically for M1 Macs and not previous generation Macs as a kind of an example. And then you would build it accordingly. This is the editor target for Mac. Or if you were building a Mac server, or if you're building like a Linux server, you would be very specific. Gas ability demo, Linux server would be the name for it. You get the idea. But that, in a nutshell, is targets. I actually meant to talk about these first because of how simple they are. There are a plethora of other settings and flags that you can set for targets. So if we go down this list here, you can see that there's a lot of Boolean flags for different things that you can include or exclude from compiling. Too many for me to go over, really. But that'll give you an idea of the sorts of things that that build targets can do. And to give you an understanding of what that actually does for you, I will go back to Shooter Game once again, proving yet again that that I'm not done with Shooter Game yet.
Old Faithful.
That's my secret. Shooter Game is never done. I think I got my voices mixed up there. I think I was going for... I think I wound up with a 90s action hero instead. So when you go to package project, the build target here is what this is referring to, those target.cs files. And so when you're in like a blueprint project, you'll only see like the game target. But when you add the server target, like I showed you here, like there is in Shooter Game, you will see these other different types of builds available. And similarly, these targets will be available, I believe. Go back into this. Let's see. That's the configuration. Build configuration is a different thing. And that's actually another setting that you can use in your targets if you want to be really, really specific about what type of build you're doing. These are basically saying, all right, shipping is the final shipping version of the game. It's going to strip out a lot of debug symbols and things like that. Development is going to have a certain number of debug symbols, and then debug game is going to have a certain amount of debugging functionality. So you do shipping, you're not going to be able to attach and debug the way you can with these other types of configurations. But you can specify those in your targets as well if you really, really want to get that specific. At least I'm pretty sure you can. Yeah, configuration is another one that's available there. So much information. It's hard to keep it all in my head. So pardon for looking at my cheat sheet. But let's see.
Why you write documentation, so it all exists for everyone.
Yes. And I believe that when you use UAT to run a build, you can probably put in a configuration equals specifier to tell it which of those targets you want to use. Pretty sure. I haven't had to do that lately. I've been doing mostly game builds, but you get the idea at this point, I think. So at this point, I'm open to questions.
Cool. Well, we got a few. So, let's see.
With how scatterbrained I've been, I don't wonder.
No, not at all. And sometimes people come in at different steps, so there may be a couple things we've already covered, but we can reiterate for those folks that didn't catch it all. But so somebody was asking if you could explain how the build tool handles include paths. So when should you set them? Sometimes the C++ wizard generates code with incorrect includes with when you have folders within a module.
Okay. The exact logic for that sort of thing, I am not familiar with. So I would have to come back to you about that question. But basically, if you know that there is a subfolder in your source directory, like I made with the uh, ability demo like this, if it's just in the private and public folders at the top level of the module's source code, then you don't have to go that deep. But
Mhm.
if you have subfolders, like you go into public and then there's an attributes, and then go into private and there's an attributes, you want to make sure that the include path includes this folder. I don't know exactly how build tool itself is parsing that. Like, I'm not that familiar with the under the hood workings of it. I know how it impacts your workflow mainly,
Mhm.
but that is basically the rule of thumb. So you'll probably, if you have the wizard generating incorrect include paths, then you're just going to have to watchdog it a bit.
All right, cool. They're wondering, so we've been setting private and public modules.
hmm
So like, what's the difference between doing that? And then, when do you select each one? Or like, why would you
Okay,
set it as private versus public?
so private and public are applied at multiple different levels here. So I'm going to try to disambiguate all of them. I will use this opportunity to talk about all of the private and public that you could run into. So I'm going to go back to the ability demo here. So you go to source, and you've got, so first off, there is the private and public specifiers in the C++ code, of course. That controls whether or not a class, an external class, can reference the functions or classes that are under those headers. So a public class can be included or can be referenced in another class. You can have an object with that type. You can have a pointer to an object with that type. But if it's private, then you can't declare a variable with that name in that type in another class. With public, you can access it from outside. Private is actually super restrictive. That means you can't even inherit from that class. It is end of the line as far as the polymorphism inheritance tree is concerned. And as far as you are concerned, this thing is going to run by itself and not do anything else. Protected means nothing can access its functions from outside, but yeah, it means nothing can access it from outside, but it can be extended. And then similar things apply to variables and functions. If it is a public function, you can call it from outside of that class. If it's a private function, you can't extend it either. If you make it protected, then you can extend it, but you can't call it from outside. With the public and private folders in the modules, this restricts visibility of code to other modules. So anything that has so private always has the CPP files in it. Whatever type of module you're making, whatever code you're putting in, whatever your intentions for its visibility, the CPP files all go into the private folder. If you put a header in the private folder, then it is visible to any classes inside of this module, but it's not visible to any classes outside of this module. So other modules can't include that header. They can't, they can't make references to it. It's entirely a self-contained thing, and that's something that you would use if you have something is strictly internal, like a struct that doesn't need to be used anywhere outside of this module, or if it were used outside this module, you'd consider it a kind of design failure. There's a handful of like companion classes you might define like that, where they classes that are public are responsible for instantiating those and for calling functions from them. But you don't really want to have like throughput. You don't want those companion classes that are kind of attached to it, like Pilotfish. You don't want them to have visibility outside of this module because it would get messy. So you're kind of limiting outside exposure of this code to stuff that you think is important. Yeah, public, it's accessible outside this module. Private, it's not accessible. And this overrides basically whatever the specifiers are in your C++ code. This is more important. So with public, it will honor the rules of your public and private and protected specifiers as normal. With private, it's all sealed off. There's nothing you can do to look at it from outside this module. As for the dependency rules, because there are public and private dependency rules, basically that refers to whether or not you intend to use classes from that module in public or private classes, as defined here. So if you are using, well, public and private C++ files, rather. So if you are using forward declaration, let's see if I've actually got some kind of an example here. Let's see, mainly hit sphere definition. That's not what I want. Go here. Okay, there we go. So let's say you've got a function like this, and it's got class A controller in here as the input parameter, as the argument rather. This is a forward declaration. This is saying this class exists, but I'm going to define what it is later. And so when you go into the CPP file, oh no, it's going to crash. It's going to crash.
Oh no.
I accidentally moved the window and it's going to crash. Of course it did. Please recover the selected file. Yeah, I'm not sure what's going on that's making it so crash happy when I tear out windows like this, but it really doesn't like that today. Okay, so like I said, if you use a forward declaration like this, you are expected to then include the header file for that class inside of the CPP. So you can see a shooter weapon here, forward declaration of the weapon type, and then I go into the character and it actually includes shooter weapon here. As long as I am following this paradigm, this is the include what you use paradigm, where you basically avoid including unnecessary things in your header files. If I follow this paradigm, then I can get away with whatever module includes shooter weapon being a private dependency instead of a public dependency. And that means that it's going to be restricted from showing up in the header file if the header file is in a public folder. But it's not going to be restricted from showing up in the CPP if it's being used completely privately like that. That is basically there to speed up compile time. The whole include what you use paradigm is about speeding up compile time. So if I include shooter weapon in this header file for the character, did I say shooter weapon? I'm doing so much talking. I'm second guessing whether or not I said what I think I said. If you include shooter weapon in this character, it's going to need to compile all of those classes before it gets to this. It's going to try to include all of their code, everything from their headers in this file, and it's going to be messy. You're doing a lot of redundant compiling is what's happening. Basically, you do this to enforce include what you use, and just try to keep from doing all that unnecessary compilation and just speed up your build times, in addition to the extra speed you get by separating things out into modules.
Chat's also commenting how it can help you prevent or avoid circular dependencies as well.
Right, so circular dependencies. I remember a guideline on avoiding circular dependencies, but I don't remember what it actually was.
But you don't remember the guideline?
I don't remember so that's a matter of being careful a lot of the time. But yes, forward declaration and this whole paradigm is intended to avoid circular dependencies, where one header includes the other header, and you've got two headers including each other. But in terms of the dependency rules in the build.cs files, I think that's mostly a matter of being careful. I'll have to check on whether private dependency handles that use case for you, or whether you have to just completely be very careful about the dependency chain that you are setting up. But circular
forward declaration of classes was helping avoid that.
Oh yes, forward declaration is essential for avoiding that. Yeah, absolutely.
But yeah, so they are also asking, can the build option type equals target type be used to filter specific public and private definitions or implementations?
Target type, huh? So target type, we're talking about which file are we talking about editing here? That's like running a build, yeah?
Yeah, I was asking the build option type equals target type. So
Okay.
Can that be used to filter public and private definitions?
What that'll filter is which target you're using, I think, if I'm understanding correctly. Basically, you're picking between which one of these target.cs files you want to use as the rules for your compile. It can be used to filter a lot of different things, but whether or not it's a public or private class in terms of its exposure to other modules is going to be determined by the folder you put it in.
All right. Let's see. Someone was asking, is it necessary to build the project configuration in shipping mode if you're going to package the project with shipping enabled?
That's a really good question. That's
a really
good question.
If we're not sure, we can always follow up on these later and add them into like the forum post of the event.
Yeah. I want to get back to that one. That's something that I'd like to investigate. I don't know of a use case where you would make a shipping build and not have shipping enabled. But I'll check up on what that's doing.
Sure. Let's see. Someone's asking, we've mentioned all of the .cpp goes into the private folder. What's the difference between putting the .h file in the public folder and root folder of a module?
Okay, so if you put the .h in the root folder, that's going to more or less treat it as private. I have never tried mixing the root folder with a subfolder for the CPP. I don't know what it's going to do in that case, but I think that if you put one in the root folder, you're probably supposed to put the other one in the root folder as well, because it's kind of depending on this parallel construction with the folder structures for each of them.
All right. So someone's asking if they can run arbitrary scripts as part of the module build step. For example, if they need to generate files for the first time in a module.
Interesting. So is that referring to like a custom script that you want to run aside from header tool and build tool?
It seems that way.
Okay. There are definitely ways to incorporate something like that. The exact method is something I would have to touch on at a later time because I haven't dug into that side of working with build tool yet. But theoretically, yes, you could absolutely put your own pre-build or post-build process together and add it on to this. One way that you would do that is one way you would do this is using UAT. So UAT is the Unreal Automation tool, and it is primarily used by going to, let me see if I've got it in here. Nope, it's going to be in some other folder somewhere. Where the heck is it? So you should see somewhere in your project folder runuat.bat, or actually it's probably in the engine folder. That's probably why I'm not finding it. Look at Win64. Nope, not finding it in here either. I wonder where runuat went. It shows up in a lot of different places depending on what type of build you're using. But you call up runuat.bat. Maybe that's under platforms. Nope, not under platforms. How am I losing so many files here? Oh, batch files. Yeah, there it is. Okay. Engine build batch files. There's runuat. And there's a bat, a dot command, and a .sh, depending on if you are on Windows, Mac, or Linux. So what you do with UAT is, let's see, command prompt. You take and you cd over to here. Excuse me, but don't tell me I forgot how to use command prompt. See, how am I forgetting how to use command prompt? See,
You're saying you
surely
need to change
CD
the
should take me there. Oh yeah. Darn it, semicolon.
Nothing like being live.
I don't understand this. What is going? Why wouldn't this work? CD
They're
should
saying
go
you
to the
don't
B drive at that point.
need CD, just D:.
There we go.
Thanks, Chad.
Sheesh. Sheesh. Okay. There we go. Now CD does what it's supposed to do. Okay. Thank you, chat. That was very silly of me. I I should remember all of that stuff. So basically, you can use run UAT to do the build cook run command, and you do that with a number of specifiers. So that's project equals shooter game, platform equals Win64, target equals should be able to say target equals shooter game, but I'm just going to leave that out for right now. Just not get too fancy. And then if you put the build specifier in for this, that will say just run build tool and give me a build of this project. Let's see, configuration, probably configuration. That would be a shipping build. And then I add build if I want to do the code, cook if I want to cook content, which is something you do to stage for creating the final packaged version of your game. Stage will put together a nice, neat executable in a folder for you. And then run will actually tell it to run. And then there's a lot of other things that you can do to tell it what device you want to run on as well. So if you want to remotely deploy it to a device, that's what it'll do. This command is actually what underlies the packaging and launching commands in the editor. So when I go to package project, this is pulling up UAT and running build cook run. And that's one of the jobs that Unreal Automation Tool has. The reason that you would do this with a command prompt like this is so that you can write a script that will automate this process. So if you have like 3 or 4 different platforms that you need to build for, you could write a script on a build server that you've made, just a computer that you've set up to automatically run builds for you every night. And you could write a script that says, hey, do this run UAT command every night at 7 o'clock, and then do these other 2 when it's done. You could add anything before or after calling up UAT to do the build. And theoretically, you could also add things into UAT. Well, I don't know about adding things into UAT. Probably don't want to say that, but if we have UAT's source code in here, then you'd be able to do that. But the point is, the easiest way to add other steps, other scripts that you want to run, or other code generators that you want, in addition to header tool and build tools normal processes, is to make another script that will automate this UAT call for you. And before you do build cook run with UAT, you run your other script. So I actually had a better answer than I thought.
No, that was great. I think that's about all we have time for today. Is there anything else you would like to leave the community with before I get into my outro spiel?
Again, I want to thank Ari Arnbjornson, who helped out with the new modules information that we surfaced. This is going to help make more complex, ambitious, or larger scope projects a lot more manageable for a lot of people. I want to thank everybody in chat for bearing with me as I word saladed all over the place and maybe misspoke a couple of times. And I also want to thank them for spotting my boneheaded errors as my nerves get the better of me sometimes.
You were great. Don't even worry about it.
Oh, I appreciate that a lot.
There's lots of information to try and digest and sort out here, so I think you did wonderfully.
Thank you very, very much, Amanda.
Well, thank you again for joining us. It's, always a pleasure having you on the stream, and you always have lots of great information and resources for the community. To you all out there, again, thanks for joining us this week. We're going to drop a survey in the chat. Let us know what you thought of today's stream and what topics you'd like to see in the future. Again, these streams are for you, so let us know what you'd like to hear. As always, follow us on all the social medias @ Unreal Engine. And we're always looking for community spotlights. So if you want to shoot us a message at community@unrealengine.com, you might get featured in our newsreel. I feel like you have a thing, Mike.
I was going to talk about modules versus plugins. I forgot to talk about the plugins. Okay, for another session, I will talk about plugins. That'll be the next one.
All right. So when Mike returns, we'll compare those things, or we could always do a little write-up in the forums if you like.
Yeah.
And yeah, if you're streaming on Twitch, use the Unreal Engine tag, and we can maybe, well, one, we could find you, or maybe even raid you one of these days after the chat. Next week, we will have Mold3D on to talk about their development of Slay, the animated short and sample that is available on the marketplace. So yeah, join us next week for that. And again, thank you, Mike. Thank you, chat. And I hope you all have an absolutely wonderful week.
Thank you, everybody. Have a wonderful day.
See ya.